All right, here's the first example for rotational motion. It's really not that complicated, but for some reason, the symbols make people think it's more complicated than it really is. Here we go. 2 kilogram circular disc of radius 10 meters is initially at rest. You would typically write that and think to yourself, all right, VI equals 0. At a constant force is applied, giving it an angular acceleration. You'd be saying, all right, acceleration equals 2. You're usually saying meters per second squared. Here's radians. And then you said the disk reaches an angular velocity. Oh, it accelerates for a while and reaches an angular velocity of -10. Oh, by the way, this is -2. So you'd say, oh, final velocity equals -10. And we're used to saying meters per second, but this would be radians per second. And the first question is, determine the time. Okay, when you see these ideas of angular acceleration and angular velocity, there's a whole new set. Instead of VI equaling 0, it's omega I equals 0. Instead of A equals -2, angular acceleration is alpha equals -2 radians per second. And instead of final velocity, it's omega final equals -10 radians per second. And time, thank goodness, time is still time. If you had these here, I think most people would say, oh, I've got to go VF equals VI plus AT, and you can figure out time. It's the same equation, but now with these symbols, it becomes omega final equals omega initial plus angular acceleration times time. -10 radians per second equals 0 plus -2 radians per second squared multiplied by time. Divide both sides by -2 radians per second. What times -2 is going to give you -10? T equals 5 seconds. That's the first part. 5 seconds is the answer number 1. For the second one, now we want to know determine the radians. Radians is essentially the angular distance, right? Radians is angular distance. So if you're looking for the distance, you'd want to use one of the distance equations. Delta D equals VIT plus 1/2 AT squared is what you're so familiar with. But now that would become changing the angular distance equals omega initial times the time plus 1/2 the angular acceleration times the time squared. So we want to know delta theta equals initial velocity is 0 multiplied by time plus 1/2 the angular acceleration, -2 radians per second squared. We figured out the time was 5 seconds squared. 5 seconds squared is 25 seconds squared times -2 is -50 times 1/2, -25 radians. That's the answer to number 2. That's it. Key thing, the fact that this is negative, just as the positives and negatives in the translational motion tell you it's to the right or to the left, like positive is to the right, positive is to the right or up, and negative is to the left or down. With angular motion, positive is counterclockwise and negative is clockwise. I don't like that circle. Get rid of that one. It's supposed to be a circle. Clockwise. Negative is clockwise. So this is 25 radians, 25 rad in the clockwise motion, clockwise direction. All right, that's it.